You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Space junk, the real risk, and what to do about it. Rarely has a Hollywood movie placed a real danger so squarely into the minds of a general public who had never thought too much about it than was done with 2013's Gravity, starring Sandra Bullock and George Clooney. The movie portrayed a runaway syndrome in which orbital debris from an anti-satellite missile explosion struck other objects in orbit, destroying them and creating even more debris, ultimately becoming an irrecoverable cascade which destroyed nearly everything up there and rendered the entire low Earth orbit useless for generations. We all left the movie theater wondering, I know space junk is a problem, but could it really get that bad? Well, today we're going to see where the line lies between fact and hyperbole. There's actually theory that attempts to answer this question, as it's fairly self-evident that debris in orbit poses a danger to spacecraft, and also self-evident that the amount of debris is increasing as we've launched more and more stuff over the decades. A NASA astrophysicist named Donald Kessler co-authored a paper characterizing the problem in 1978. Kessler described three scenarios. In the first, the rate at which new debris is created by collisions of existing debris would be less than the rate at which pieces naturally decay and re-enter the atmosphere, so the problem never grows. In the second, the rates would be the same. But in the third, collisions among existing debris would create new debris faster than it could fall back to Earth, triggering a cascading chain reaction that is unrecoverable. This third scenario, the cascade resulting in what he called an intolerable hazard, became known as the Kessler syndrome. Currently, we're somewhere around the second scenario. Although we're putting a lot of stuff up there much faster than it's coming back down, actual collisions are still pretty rare. Although keep in mind, the next catastrophic collision is inevitable, and might happen tomorrow, or in 1 year, or in 5 years, and it might even happen after I record this and before you hear it. And some of you are hearing this episode in the future after it's already happened. So this is a good time to look at the actual scope of what's up there right now. And by right now, I mean as of this recording, which is May of 2021. To get this, there are a number of places we could go, but you won't go wrong checking in with the Orbital Debris Program Office at NASA's Johnson Space Center. Here is their assessment of what's up there right now. More than 23,000 orbital debris larger than 10 centimeters are known to exist. The estimated population of particles between 1 and 10 centimeter in diameter is approximately 500,000. The number of particles larger than 1 millimeter exceeds 100 million. As of January 1st, 2020, the amount of material orbiting the Earth exceeded 8,000 metric tons. But hold on to your socks, because those numbers are about to start climbing dramatically, probably to 10 times what I just read. The reason is not an increase of junk, but an improvement in our detection capability. In 2020, the new version of Space Fence was declared operationally ready. What is Space Fence? It's the primary tool of the U.S. Air Force's space surveillance system, which took our knowledge to where we are today. This new system is located on Kwajalein Atoll in the Marshall Islands, and a second facility may also be constructed in Western Australia. It's a pair of big buildings, the entire roofs of which are radar antennas. One building sends, the other building receives. It operates in the S-band, which is good for punching through the atmosphere with minimal attenuation. Space Fence will make 1.5 million observations per day, and most estimates are that it will find and track some 200,000 pieces of orbital debris that are 10 centimeters or larger. So that's a lot of junk. And obviously it's a lot more than satellite launches alone can account for. As of the end of 2020, there were 3,372 satellites up there right now, either operational or dead. How do we get from that number to an estimated 200,000 pieces of large debris? Through collisions, explosions, and tests of anti-satellite weapons. For this, we'll have a look at Johnson Space Center's article, Top 10 Satellite Breakups. There have been many such breakup events, but two in particular are by far the worst offenders, between them responsible for nearly 5,000 pieces of debris large enough to be tracked, and in orbits stable enough that they're still up there after more than a decade. One of these was in 2009. The active 700-kilogram Iridium-33 communications satellite and the defunct 900-kilogram Russian military satellite Cosmos 2251 collided at a closing speed of an incredible 42,000 kph. The two craft were predicted to miss each other by 584 meters, and this wasn't even the closest of the 400 near misses the Iridium satellite network evaluated each week. No evasive action was taken, highlighting the fact that even with our best predictions, sometimes we're going to get it wrong, as we shall do again. But by far the most destructive single event had come 2 years earlier in 2007. China destroyed their 750-kilogram Fengyun FY-1C weather satellite using their SC-19 anti-satellite missile system, which drew international condemnation. Nearly 3,000 pieces of debris large enough to be tracked, almost 15% of all tracked space junk, still remains in orbit. Today, half of all collision warnings are triggered by one of the pieces from this explosion. Other nations have deliberately destroyed satellites as weapon tests, including the United States, but these have been satellites in orbits that resulted in their debris re-entering before they could become huge problems. My exhortation to all nations worldwide, in case they're listening, don't do that anymore. A question that many people ask is about the Starlink network of satellites that SpaceX is currently launching to provide internet service. Even as nearly 1,500 Starlink satellites are already in orbit, various plans call for as many as 12,000 eventually, and possibly even 42,000. Complicating this further is that Amazon plans its own Kuiper network of more than 3,000 satellites into the same orbit, and the OneWeb network has already launched some of its 650 planned satellites into a slightly higher orbit. If all this sounds like a recipe for disaster, it probably is. However, this is mitigated somewhat by the fact that these satellites will operate at the very lowest of low Earth orbits, which facilitates and quickens their natural orbital decay and re-entry. In addition, all these satellites will deorbit themselves when they near their end of life. In theory, anyway, it is inevitable that some will break down and fail to perform this maneuver. The companies also seem to be bickering among themselves in court about who should get out of whose way should a collision be predicted. All in all, low Earth orbit is in for some interesting times. The outlook is, in fact, quite grim. Today, the space surveillance system generates an average of 21 collision or near-miss warnings every day. And of all those 23,000 tracked objects larger than 10 centimeters, only about 1 per day deorbits on its own. The ratio of stuff that goes up and multiplies through collisions to stuff coming down on its own is grossly lopsided. NASA uses a three-dimensional orbital debris evolutionary model called LEGEND to validate prediction models for orbital debris. Considering the number of uncertainties involved, LEGEND does not spit out convenient numbers telling us the probabilities we're all wondering about right now. But in every possible scenario, we expect to see more and more satellite collisions and debris counts that only go up and up. So, this leads us to our ultimate question. What can be done about it? There are quite a few concepts and proposals for spacecraft to act as vacuum cleaners to get rid of some of that junk, but unfortunately, my unvarnished assessment is that they're all cockamamie and completely implausible. The problems of doing this are enormous. Stuff in orbit moves at tens of thousands of kph. To get your vacuum robot close enough to a piece of debris to do anything, you have to at least come close to matching its speed, which is an energy cost that alone effectively limits most vacuum robot designs to a single piece of debris, an impractically expensive proposition. Some propose harpooning, tethering, or bumping the junk, or heating it with a laser, or pushing it with an electron beam, all with somewhat unpredictable outcomes. The most exotic concepts use an electrodynamic rope or net, maneuvering themselves against the Earth's magnetic field using solar electricity, and hoping to catch the debris as it comes by. Recalling that these pieces are coming in with much greater speed and energy than a howitzer shell, the concept seems hopelessly failure-prone. Other designs float in the upper atmosphere and fire puffs of air up into space to slow down any debris that enter them. But the effectiveness of this, in even the best scenario, would be limited to just the very lowest of debris, the same debris already most likely to deorbit on its own. There is, in fact, only one thing that we can do about the space junk problem, and that's to stop making the problem worse and hope to stay in Donald Kessler's second scenario. This can only be done with policy. All spacefaring nations do have their own policies which continue to be improved. The United States' National Space Policy was updated in December 2020. Also, the United Nations Office for Outer Space Affairs publishes guidelines for satellites intended to make them more likely to come down on their own. The Space Debris Mitigation Guidelines of the Committee on the Peaceful Uses of Outer Space. But you can make all the policies you want. Half of all dead spacecraft currently in orbit fail to meet those end-of-life guidelines. In the official Skeptoid conclusion, this best-case scenario of simply being lucky enough to stay below the Kessler syndrome is ultimately a fool's errand. There are simply too many potential points of failure that happen every day, and literally centuries of future opportunities for any one of them to cause a cascading event. The probability is that events worse than those listed on Johnson Space Center's top 10 list are, given enough time, virtually inevitable. As a huge fan of space programs, I find this conclusion to be at once sobering and gravely disappointing. And of course, I hope to be very, very wrong. Nevertheless, I will maintain a forward-looking attitude and count on vacuum cleaner technology to continue to be developed, which is already happening. Let's just hope we beat the clock. A great big Skeptoid shout-out, and a promise not to fire into orbit, Skeptoid Premium members GP from Wildemar, California, Gorgeous Baby Niblet, Daniel O., and Apurva from India. Let me give you a shout-out too. It's easy, just log into the members portal at Skeptoid.com and click Shoutouts and Stories to tell me what you want me to say. Remember, Skeptoid is a 501c3 educational nonprofit. We depend on your monthly micropayments just to keep this content available to all the people out there who need it. Join us in this mission. Just come to Skeptoid.com and click Go Premium. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.